Even before the Hubble Space Telescope's launch in 1990, astronomers began posing the question, what is the next step after Hubble? The answer, James Webb Space Telescope. And in this video, we will be talking about its history and what it has in store for us. Get ready for this cosmic trip. Let's start, shall we? In 1989, the Space Telescope Science Institute, STCI, and NASA co-hosted the Next Generation Space Telescope Workshop at STCE. The focus was the science and technical capabilities of an observatory that would follow the Hubble Space Telescope after it was decommissioned, which was estimated at that time to be 2005. Then in the next decade, an STSCI committee recommended a significantly larger telescope capable of observing infrared light. NASA selected Goddard Space Flight Center and STCI to study the feasibility of the Next Generation Space Telescope. 3 independent government and aerospace teams determined that such an observatory is feasible. Then, NASA selected teams from the Goddard Space Flight Center, TRW, and Ball Aerospace to fine-tune the telescope's technical and financial requirements. Lockheed Martin, Ball Aerospace, and TRW, also partnering with Kodak and ATK, conducted Phase A mission studies, including preliminary analysis of the design and cost. Based on 2 Phase A studies, NASA selected the design of TRW Ball Aerospace to continue in Phase B detailed design studies, which examined the performance and cost of the chosen design. The telescope was renamed from the Next Generation Space Telescope to the James Webb Space Telescope. In Phase B, TRW and Ball were awarded the observatory contract, but changes followed immediately. Northrop Grumman acquired TRW and worked with Ball to develop the observatory during Phases B, C, and D, while NASA selected the Flight Science Working Group and the team responsible for developing the near-infrared camera, NIRCam. After that, construction began on certain telescope parts that required extensive long-term work, in particular Webb's science instruments and the 18 segments of the primary mirror. Plus, NASA approved the use of the European Space Agency's Ariane 5 rocket to launch Webb into space. The science instrument teams for the near-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, passed critical design reviews and initiated construction of the flight instruments. All of Webb's essential technologies were tested successfully under flight conditions. Now, NASA had the Webb mission reviewed by internal and external groups. The internal preliminary design review and external non-advocate review concluded that the plans and designs had reached the maturity needed for NASA to commit to phases C and D, which entail a detailed design, procurement, testing, and assembly of the telescope and observatory components. Construction began in earnest. The integrated science instrument module structure, built to house Webb's 4 science instruments, arrived at Goddard Space Flight Center for testing. In 2010, Webb passed its mission-critical design review, which signifies that the integrated observatory will meet all science and engineering requirements for its mission. Moving on after 2010, in 2011, Webb's mirrors were completed. They were beryllium coated in a thin layer of gold and had passed cryogenic testing, which exposed them to the frigid temperatures they would be subjected to in space. Next year, Goddard Space Flight Center received 2 of Webb's 4 science instruments, the mid-infrared instrument, MIRI, and the near-infrared imager and slitless spectrograph, NIRIS, as well as Webb's fine guidance sensor from the European and Canadian space agencies. Webb's secondary mirror and the first 3 primary mirror segments also arrived at Goddard Space Flight Center from Ball Aerospace and Technologies Corp. Northrop Grumman and partner ATK finished constructing the center section of Webb's backplane structure, designed to hold the telescope's primary mirror segments. Then, the 2 side wings of Webb's backplane structure were completed by Northrop Grumman and ATK. Webb's 2 final science instruments, the near-infrared camera, NIRCam, and near-infrared spectrograph, NIRSpec, as well as the remaining primary mirror segments, were delivered to Goddard Space Flight Center. Manufacturing of spacecraft parts, such as fuel tanks, gyroscopes, and solar panels, began afterward. Cryogenic testing of the Integrated Science Instrument Module, ISM, including all 4 instruments, began to demonstrate the performance of the instruments as well as the electronics used to communicate with the instruments. Cryogenic testing of the Integrated Science Instrument Module, ISIM, was completed between 2015 and 2016. The 18 primary mirror segments were mounted into the backplane, along with the secondary mirror and support struts. The primary and secondary mirrors were integrated with the aft mirrors and the ISIM to create the unit known as the optical telescope element. Then, the optical telescope element successfully underwent cryogenic testing in a giant thermal vacuum chamber called Chamber A at Johnson Space Center. Following the successful completion of its final thermal vacuum test, the optical telescope element was delivered to Northrop Grumman in Redondo Beach, California, bringing all of Webb's flight components under one roof. The first successful communications tests were run from the Mission Operations Center at Estes to the telescope's spacecraft on the ground in California. In 2019, for the first time, Webb's spacecraft elements, the Sun Shield and Bus, successfully passed acoustic, vibration, and thermal vacuum tests, which simulated the rigors of the launch environment as well as the extreme vacuum of space. Engineers successfully connected the two halves of the Webb telescope, the optical telescope element and the spacecraft, at Northrop Grumman. Moving on, the 2020s. 2020 saw Webb fully folded for the first time and completed final environmental testing to prove it can withstand the shaking and jostling of the launch environment. Webb's Sun Shield was also deployed for the final time on Earth. Next year, Webb was folded and stowed for launch for the final time. STSCI announced the selection of Cycle 1 general observation programs, rounding out the science Webb would conduct during its first year in space. Webb was shipped to the Guiana Space Center, Le Centre Spatial Guyanais, CSG, in Kourou, French Guiana, for launch. December 25, 2021, NASA's James Webb Space Telescope launches. NASA's James Webb Space Telescope launched at 7:20 a.m. EST on an Ariane 5 rocket from Europe's Spaceport in French Guiana, South America. Ground teams began receiving telemetry data from Webb about 5 minutes after launch. The Arianespace Ariane 5 rocket performed as expected, separating from the observatory 27 minutes into the flight. The observatory was released at an altitude of approximately 75 miles, 120 kilometers. Approximately 30 minutes after launch, the Webb telescope's unique solar array unfolded, and mission managers confirmed that the array was providing power to the observatory. Within the telescope, there are 4 state-of-the-art instruments with highly sensitive infrared detectors that will study infrared light from celestial objects at unprecedented resolutions. Webb will deliver its first images at the end of a 6-month commissioning period. The James Webb Space Telescope, built in collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, will seek the light from the first galaxies in the early universe, study how galaxies and stars change over cosmic time, observe planets orbiting other stars, called exoplanets, and even study our own solar system. July 12, 2022, Webb's first images display the universe in a new light. On the evening of July 11, 2022, President Joe Biden unveiled the first full-color image from the James Webb Space Telescope. The near-infrared light view of galaxy cluster SMACS 0723 is the deepest and sharpest image taken of the distant universe to date. The following morning, full-color images and spectroscopic data for an additional 4 targets were released, each revealing cosmic features that had never been captured in such detail. Webb's first observations demonstrated the telescope's ability to finely detail the universe through cosmic history. These 5 images showed the wide array of capabilities of all of Webb's state-of-the-art cameras and spectrographs. The release of Webb's first images and spectra kicked off Webb's science operations, with astronomers around the world beginning to study many different objects, from nearby planets to distant galaxies in the early universe. Nadia Zakomska, a former member of IAS and currently a visiting professor at Johns Hopkins University, heads a research team that has been collaborating on JWST projects since 2017. According to them, talking about the telescope's future plans, they said that their scientific pursuits extend beyond traditional astrophysics, delving into the complex realms of supermassive black holes and their surrounding galaxies. With the launch of JWST, their efforts are centered on unraveling the mysteries of cosmic phenomena, such as pairs of quasars originating from the intricate dance of merging galaxies. These observations are positioned to shed light on the complex relationship between galactic evolution and the massive entities residing at their centers, marking a groundbreaking effort to unravel the cosmic story. Furthermore, their investigations delve into the dynamic phenomena of galactic winds, generated by the immense forces unleashed by quasars, and their significant influence on the cosmic environment. With careful study, they aim to understand these cosmic phenomena and their influence on the universe. Their journey ahead is filled with endless possibilities, inviting exploration from our galaxy's heart to the farthest corners of the observable universe. And that's it for this video. Please click the like and subscribe buttons down below if you found it useful. To make sure you don't miss any uploads, tap the bell icon. Share the video and comment down your thoughts. See you in the next one.